Okay, good morning, July 12th. I forgot to hit record, so I'm going to back up just a little bit. Today, we are going over, you will see in the classroom, a notebook called Basic Charts. Basic Charts. So these are one-liner, quick and dirty plots for different types of data using just the Pandas library. So download basic charts to your notebook directory and follow along. Up to here, all I've done is prepare uh, a data frame. And you've seen this data frame before. It's the Penguins data frame out of Seaborn. Okay. And now I think everybody's caught up. Okay. Now, remember from chart types, to get a quick look at the nature, the overall values and shape and whatnot of a single variable, single continuous variable, we draw a histogram, which will show you, remember, it creates bins, and then the height of the histogram is how many values fit in that bin. The bin could be like, 0 to 5, and then 5 to 10, 10 to 15, whatever. Both Excel and Python and Pandas here default to automatically picking the bin size so that you've got about 6 or 8 bins, depending on the data. And yeah, this method is no different. So what we're looking at here, this one line of code is a data frame, DF. That's one column of a data frame, right? A Pandas series is one column of data. And we've got the body mass in grams, body underscore mass underscore grams. So that's what DF and the brackets is, just a column of data. And then we use dot to get into the methods for a Pandas series. Now, there's a dot plot dot hist. Hist is for histogram. But what that means is there's a module inside of Pandas that kind of further subdivides functionality, and you'll see that in Python. So just know that there's almost like a plotting library inside of Pandas. So we can't just say, data frame body mass dot hist. We have to tell it the dot plot submodule. So dot plot dot hist, no parameters, no nothing. It goes, okay, here's a column. Doesn't matter how many values are in there, but here's a column of continuous data. Draw a histogram of it. So we'll smack that and hit it, and you'll see that the data is from around 3,000 to around 6,000 grams. And we'll go back up to our df.head, and sure enough, that's what we're seeing: 3,750, 3,800, 3,250. So that's all making sense. But what we're seeing here are, and it's tough to see them because the raw histogram doesn't show any space between the bins, the bars in the histogram, but you can get an idea of the shape of the data. So it's looking like it's slightly skewed with most values to the left, and then it tapers off, and you've got a few outliers that are really heavy, but it's looking like your median might be somewhere around 3,600, give or take. But so you see the distribution of the data. It's relatively normal. It's not perfectly normal, but it's pretty good. It's just skewed on the lighter side of body weight. But that's it. One line of code gives you a histogram, just like if we were to, write this data out to a CSV and pull it up with Excel. and click on that column and do insert suggested charts histogram, something very similar would come up in Excel if you gave it no parameters. Well, in the next couple of libraries, we'll start to see that there are, in the next couple of notebooks, I apologize. In the next couple of notebooks we'll look at, there are ways to shape virtually every, or to adjust virtually every aspect of a chart, from the title to the axis titles to the colors, the scale, those sorts of things. But that's using a pandas method to draw a histogram. So what you're not seeing is under the hood, pandas uses a library called matplotlib. And there are parameters you could send to the .hist method. Yeah, actually, .plot is the module. .hist is the method. There are parameters you could send to it to adjust the look of this histogram, but by default, it does the best it can, and that's not a bad looking. That's a fairly useful histogram. You can see the most frequent body measurement is somewhere around 3,500. That top one is at 70. So there were 70 penguins in that bin that were somewhere between what, 3,400 and 3,600. Any questions on a histogram? What that shows you about your data? All righty, pretty straightforward graph. Okay, so we use a histogram to look at continuous data. Lock that in. Hey guys, I need 15 seconds. I forgot to grab a bottle of water. I'll be right back. Right back. Whew. Amazing how quick you dry out. Yapping. Okay, so now we'll use one way to look at a single categorical variable and a bar chart. And remember, it looks like a histogram, but it's not. Histogram shows the number of data elements, data values in the bin, which is different than a bar chart, which we will run slightly differently than before. For one thing, we need to call the dot value counts method to get the categorical variable into how many are in that category. We need to count the occurrences of that categorical variable. And then we call the dot plot method, just like we did, or the dot plot, dot plot method. But there's two ways using this matplotlib and pandas. You can specify the type of graph in dot notation, and it will call a method to do that. Or you can call dot plot and pass it a kind equals variable. And the kind equals will take, there's like 15 different plots that you can say kind equals, and we'll get into that a little bit more when we talk about matplotlib, and I'll show you what I'm talking about, the conventions there. So what this does is it counts the unique values in the species column and plots it in a bar chart. So this shows that we have 140 odd Adelaide penguins and 120-ish Gentoo penguins and 60 or so chinstrap penguins. And we can prove that by just, here, I'll just add a cell. DF species dot value counts, and just show the output of that method itself. Yeah, 152. 152 Adelaide penguins. That looks about right. 124 Gentoo penguins and 68 chinstrap penguins. So there you go. That works really well. And I hope you guys are getting comfortable enough to do things like that, to add a code cell and what the heck, what happened? What's the data type of this? And, and start pulling this stuff apart. I'll go ahead and get rid of that though, so that I don't accidentally leave it in next time. Okay, so yeah, a bar chart is a way to count, visually show that there are, like, for example, there are twice as many Adelaide penguins in this data set as there are chinstrap. And you can just see that visually. Okay. Now, almost identical. I believe all I changed here to go from a bar chart, which a bar chart and a pie chart kind of show the same proportion of category of a categorical variable, and which category contributes to the whole. The bar chart doesn't show you the whole. A stacked bar chart will show you 100%, and then the little sub colors inside show you which category contributed to the entire bar. Pie chart shows you 100%, and then which one proportionally is represented. So one line of code, quick pie chart for, again, this is a categorical variable, a series, a pandas series, a column in a data frame. And it defaults to showing you the category, just like the x-axis of the bar chart. It shows you the species, and it labels the pie chart with what that categorical variable was. It's by default. You didn't have to do it, as opposed to the bar chart up here. It's obviously needing some sort of parameter to set a chart title, but different charts are coded different ways. And there you go. And these are the default colors without telling it green, yellow, and blue. And that's how you draw a pie chart. Okay, so when we want to look at two continuous variables and how they relate, generally speaking, we throw up a scatter plot. Now there's a kind of like we did the dot hist up here, plot.hist. I'm going to switch back to plot.scatter, but I'm going to show you it doesn't really make any difference. I'm pretty sure down in the code, these do the same thing. These execute the same routines. It's just two different ways to get at the functionality. And there are always so many ways to get things done, different ways to get the same thing done. So a scatter plot here, and remember, generally, the convention is that the x-axis of a scatter plot is the independent variable. It's the thing that causes the causal variable. It's the thing that causes change on the vertical axis, up on the y. Now, I don't know. There probably isn't any causal relationship to examine here because we're just taking metrics of these birds. It's not like we're feeding them and saying that, a monthly caloric intake causes size to increase or anything like that. So in this example, I don't think it really matters. But I'm going to correlate, or at least show the correlation scatter plot of bill length and flipper length. So we'll see here. So data frame dot plot dot scatter, and we're not doing the series now, we're doing multiple variables. So you don't use the pandas series anymore, data frame species or data frame sex. You you just use the data frame df dot, just like you do df dot head, df dot tail. This is a method that is using the entire data frame, or it's a method of the entire data frame. Df dot plot dot scatter is how you call that method, but you got to tell it which two columns you want in your scatter plot. So we're going to say that the x-axis along the bottom edge of the graph is bill length in millimeters, and the y-axis is flipper length in millimeters. And yeah, there's a pretty good correlation between those two. We could do a correlation matrix. Let me do that. I'll add a code cell. I don't think I'm getting ahead of myself. Nope. So it looks like they're correlated, right? I mean, like you'd think, if the bill's longer, the fit's longer because it's probably an older penguin or whatever, better fed. But we can do a df dot core to do just a correlation matrix of all numeric fields against each other. And what do we do? Bill length and flipper length. So bill length is in the first row and flipper length is the third column. So yeah, 0.656 Pearson's correlation is strongly correlated. And I think just by looking at it, you can kind of eyeball that they are correlated. So yeah, df.core is just a data frame method, just another one of those useful ways of looking at your data. Okay, so let me get rid of that. Any questions so far? I'm doing that good?
I have a question, Don.
Sure, Alyssa.
Would you be able to do a trend line with pandas?
Yeah, well, yeah, probably. I haven't dug into all the parameters that you can send using the pandas interface to those plots, because it's using a library called matplotlib underneath. So we'll get into more detail with matplotlib, and you can definitely do trend lines in a matplotlib scatter plot. I believe you can. It would be in the pandas documentation, and it's probably like trend line equals true. You know what I mean? You just say that in there, and we got time. Let me look. Let me see. So pandas scatter plot, and I'm going to look in the actual plot.scatter documentation. And you'll see in the pandas in Python documentation, you'll see quids and kwargs, KW-args and KWDS. That stands for keyword. So it doesn't list them all. You have to go to the documentation to see what keywords, like plot line, like a trend line equals yes, colors equal this, and it will tell you all of the keywords that you can. So hang on, let me stay with me here. Come on now. Data frame dot plot. Oh, I'm sorry. Here we go. Plot dot scatter. Boom. Okay. And in the quargs, these star quargs, there's going to be keyword arguments, which these are all of the things that you could, they're optional parameters that you could send when you call that scatter. Come on now. Keyword arguments. I could have swore collection properties. I could have swore one of these would be the option to add a trend line. Stay with me. I know this is boring, but this is how it works. Adding a trend line to pandas scatter plot. On matplot, I want to add it in pandas. Well, it's not going to give me an easy answer because I've got the code to do it in matplotlib in the underlying library, but not, I can't find the parameter here in scatterplot, trendline, Python code example. Yeah, these are all going to be matplotlib. I don't know in pandas. I'll have to show you in matplotlib. Sorry about that.
No problem. Thank you.
I'm sure there's a way. Basic charts. We got a break coming up. Maybe I can find another break. And then maybe, was that Alyssa asking that question?
Yeah, it was Alyssa.
Yeah, you may find it before I do, just like you did the sub totals in pie chart or in what do you call them? Pivot tables. Okay, so that's one way to call, to create a scatter, syntax for creating a scatter plot in the using the pandas library. But this df.plot will call all, instead of having to say the dot of what type of graph and then the parameters, you can say kind equals. And there are, like I said, there's about 15 valid values for this kind equals parameter. So we'll say kind equals scatter, and then X and Y are the same as before. And you'll see it's the same code executing. It's the exact same graph. So I'm saying it's the same code executing underneath. It's just a different way of calling that functionality. Hope that makes sense. Okay, so yeah, these are like, the absolute bare bones, just taking the defaults. Okay, so yes, not in this notebook, but in we'll look at more advanced plotting in notebook 14 and 15. But I did want to show a line chart in these basic file chart, in these basic chart types. And I couldn't quickly find a data set in Seaborn that worked for me. So I went and I yanked the code out of notebook 13, the one we just covered for pivot tables, and I stuck it in here. And that opens that bank accounts, no commas CSV file, and converts the data to the correct data type. So you've seen that code before. Okay, so now by default, the dot plot method, if you don't say kind equals, it defaults to a line chart. And if you remember from chart types, a line chart is really made. I don't know if you got your camera on, if you can see me. A line chart is really made to show changes in the Y dimension, like over time, either actual calendar dates, days of the week, fiscal quarters would be from left to right on the x-axis, and then whatever variables you're looking at, whether it's like new corona infections and hospitalizations and whatnot, that was a line chart we all saw 100 million times during the worst of the pandemic. So in this data, I knew I had date going from the 1st of April to the 1st of May 2019. So it was quick and easy, and I went and grabbed this data, stuck it in a data frame, and then if you call the dot plot method with no, but you don't tell it what kind of plot to draw, it defaults to a line chart. And so I'm saying X equal date, and now it's going in, and since it's a date time variable, it's going in and it's automatically counting the amount field, the only other integer variable in the data frame, and throwing it up as a line chart. So, and it is ugly, but yeah, you see you have April 1st over here on the left, and then the labels move to the 5th, 9th, 13th. So it is chronologically in order from left to right. And then the line chart is actually showing the change in total daily amount as it goes across. And like I said, these are quick, dirty, and ugly. And since you've got so many data points there, you got 30 data points, it's kind of sketchy and really hard to see the individual changes. And you got weekends thrown in there. So, but those are basic charts. And I wanted to start off this so that you could just go, oh, well, gee, look at that. You can draw. That's my only goal here, was that you go, okay, wow, you can draw charts with Python, and they come right out on your screen, and it's only one line of code. And then it gets, like everything else, it gets more powerful, but more complex from there. So when we come back from break, if you could have at 9:30, if you could have notebook 14 pulled up, and I say you need stats exam 3 scores, but I'm wondering if that's not trouble. Don't get too far ahead of me here. But have notebook number 14 ready. And I know, don't worry about all this. This is, like I said, this goes ugly early. It goes complicated way too fast. That's the data frame. Hang on. Yeah, stats exam 3 scores. You need that one. And I thought we needed the other one. Stats exam 3 scores. and stats HW and exams.csv. Yeah, you need both of those files. Now, my question for myself is, did I put them both up there? Stats, hardware, and exams, but not the other one. I'll stick that up there, the other one, in just a second. And at 9:30, we'll reconvene. Okay, see everybody back at 9:30. Okay, we'll get started again. Yeah, I spent, I don't know, 10 minutes looking at it. It doesn't look like I couldn't find any way that from pandas, there's a way to pass a parameter down to get a line of best fit in a scatter plot. And actually, the best way to do it I found was through this Seaborn library, which is mostly in notebook 15. So yeah, I'm going to continue on and show you some examples. But again, guys, this is kind of awareness level. I'm not an expert at pandas plotting. There's a whole universe out there. And if any of you by chance are looking into using this to draw different diagrams, I'd love to help, learn more, provide more examples. I've got, yeah, a lot of different notebooks and stuff where I've dabbled in this and that, and I can see the parameters that you use for different things. But I'm just going to continue with what I got posted. I added the extra file, hardware 3, whatever it was. Let me share my screen, that you need for stats exam 3. So you have both of those data files now, stats hardware and exams, and stats exam 3 scores are both under there with notebook 14. And I wanted to show you the documentation from the pandas library. There are many other visualizations out there in the Python universe that people, they're some are like a library dedicated to a type of visualization looking at geographic information system data. So there's just like I said, an entire universe out there. But inside of pandas, it will draw all of these types: line, bar, horizontal bar, histogram, box plot, KDE, kernel density estimation plot. That looks a lot like a scatter diagram, but using 3 variables instead of just 2. And of course, you've got KDE and density, mean the same thing, but they're both legal parameters. So area plot, pie chart, scatter, and a hex bin, which looks kind of like a scatter diagram. And then all of these different arguments that you could send to the data frame dot plot argument. And the quargs, a lot of them are matplotlib plotting arguments. Quargs, options to pass to matplotlib plotting method. So we'll look at matplotlib in this next hour. Okay, but like I said, I'm not ecstatic at the material that I have. This is part of the course that we kind of get toward the end of Python, and I don't demand much of it in the way of exercises. I've only got one relatively simple homework assignment that I'll give you time to do today. But I did want to show you the power of this stuff. So there you go. I think, moving on, I think I have shown you guys part of this notebook before, uh, when it came down to, why we're plotting. And I talked about the Anscombe data set. It's four sets of 11 values that all have the same descriptive statistics, but when you plot them, they are wildly different. Here's some more useful information on exploratory versus explanatory plots, and the three libraries that we'll deal with: Matplotlib, Seaborn, and I'll go back over the ones that we covered in pandas. But I kind of wanted to start there just to show you that you can go simple. You don't have to do the real advanced parameters here. But I'm going to walk you through this notebook and take it for what it's worth. Like I said, there's no certification test at the end here. Okay, so this first code cell is pretty straightforward. We are going to import Seaborn as SNS and then load up one of the, I'll show you here in a minute, there's like 15 data sets in Seaborn. This Anscombe data set, you'll find it out there all over on the Google. It's a famous data set developed by a statistician to show the need for graphing over looking at descriptive statistics, because they don't catch everything. So in this data frame that we just created called Anscombe, we have our automagic numeric index on the left, 0, 1, 2, 3, 4, 5, 6, 7, 8. We have a column called data set that is just the Roman numeral 1, 2, 3, and 4. And then we have values, X and Y values for each of those four data sets. Each data set has 11 observations. Okay, so that is the Anscombe data set. Now, in this next code cell, we're going to bust that up. Oh, yeah. Just remember, just because you can create a plot doesn't mean there's a need to create a plot. Okay. And not every plot works for every kind of data. I've seen people trying to do scatter diagrams on categorical data and whatnot, and you need to know what plot works for what kind of data. So, all right, Matplotlib is the core library for drawing all this stuff, and a lot of the other Seaborn and pandas that we're looking at, a lot of the other libraries use it and then enhance it, kind of, sort of. But Matplotlib is the underlying library, and there's a module in particular that we're going to use called PyPlot. And the convention for that in the Python universe is to import matplotlib.pyplot as PLT. And then just like we refer to pandas as PD dot read CSV or whatever, we'll refer to these plotting methods as PLT dot something. Okay, so let's import that library. Make sure we're good to go there. Okay, now these next few code cells are they're just pandas. It's just subsetting rows like we have done in the data wrangling exercise. So what we're saying here is that a data frame called dataset 1 is equal to the Anscombe data frame, where the Anscombe data set column equals I. And remember the comparison operator, we haven't done this in forever. 2 equal signs. And then we'll look at data set 1. And there you go. So now actually that data set column is now redundant, since we've pulled it out. Okay, so now a basic plot. And remember, it defaults to a line chart when you just call plot. So Yeah, this is connect the dot in order. It's just not a, it's a good reason of why you don't you don't do a plot just because you can do a plot, because not every plot works. A line chart, like I said, generally works if things are in more of a chronological order or some sort of sorted order. And we don't have that here. So it just kind of goes, okay, and plays connect the dots. Okay. So that's the you know the basic form of the matplotlib is plot dot plot and then an x and a y axis. But there are other parameters that'll um, change its effect. Okay, so to use circles, and I think I have modified this since I ran it last. So this is creating using asterisk, using stars. This literal parameter here tells it what symbol to use in the scatter diagram, or I'm sorry, in the line diagram or in the plot. And we'll run that. Now it uses dots, and there's other symbols. It's in the documentation. There's other symbols that you can put in there. Let me see what a minus sign does. Back to the line. Yeah, it's not a legal character. Try an X. Like I said, it's in the documentation. what you can put in that third parameter. Okay. So I'll change that back to O for when I put it away. Put my toys back where they were. Okay, so again, this is using the underlying matplotlib library to draw these plots. This next code cell just repeats what we did to get data set 1, so that we're going to create 4 data frames, 1 for each data set in the Anscombe data frame. That's pretty straightforward. I'll hit enter there. Okay, now if we look at the descriptive stats for each of those, and that's where I said this gets this notebook gets complicated early, because what we're creating is a kind of a matrix of subplots on one figure, on one chart. Now I'll get there. Okay, so now we have 4 data frames: data set 1, data set 2, data set 3, and data set 4. So we will do the descriptive statistics, and then I guess I wanted to prove that they are all data frames. Okay, so data set, look at the descriptive stats. The same number of data items, same 11 data items, the same mean, virtually the same mean within decimal points. Standard deviation, 25th, 50th, 75th quartile. I mean, it looks like you're looking at the same data, at the exact same measurements almost. This last one, data set 4, has some outliers in it, so it's slightly different to show, but it makes a really good point here when you graph it. But they all look very similar, just from a descriptive statistics standpoint. But you'll see down here when we draw them, not so. So this next part just gets in. Here's the steps. You can create a figure in matplotlib, kind of like parameter by parameter, and you sort of build this figure object up. You build it up in memory, and then there's a show method that actually displays what you have built up using these different parameters. So show all that, and it looks really complicated, but then I think I do it in one code cell that makes it not so terrible. Okay, so what we're saying here, and again, I'm not shooting for mastery. I can manipulate this stuff and understand it when I'm messing with it, but I am absolutely not a guru myself. But fig equals plot.figure is a method to create a figure object. Our figure, think about like a figure in a math textbook, figure 1, figure 12. This figure is going to have like 2 rows and 2 columns. So it will actually be 4 plots on the same figure. And that's what rows 2 columns 2 equals. So we are going to add subplots using the columns and rows so that we know what we're doing in each of those 4 plots. And then we actually add the data in these 4 lines here, run the plot method to for each of the X and Y axis. And the X and Y are where these different plots are. You'll see here when I run it, if you haven't run it already. And then we're using a set title method to set the title of each subplot. And then super title for the overall figure. So there's all these parameters and methods that you use to generate a complex plot. And again, this is really complicated really early. I really need to adjust this part of the course. And then we set a tight layout method and run it. Okay, so that's what we have here is the X and Y is 2 and 2. So that's why we have 4 plots. X being, along the horizontal axis, Y being up here. So data set 1 looks like this. Data set 2 with the same descriptive statistics is this nice, I don't know what you call that, exponential with diminishing returns kind of shape. Data set 3 is all perfectly correlated except for one outlier, but that one outlier is enough to give it the exact same descriptive statistics as the other data sets. And then data set 4, the X value is 8 for the entire data set, and this one outlier way out there in the upper right hand corner of data set 4 is enough to pull those descriptive statistics over so that they are the same basically for data set 1, 2, and 3. So all of that, I apologize, just to give you a multi-part figure. Way too early in the discussion about Matplotlib. So if you're going to hammer me on a survey, this is totally earned. But I go back and get simpler again here. Like I said, I need to reorder, rewicker all of this. So parts of a figure, according to Matplotlib, these are things that you can adjust using parameters. Tick marks, where you can see the scale with a little more granularity, different plots, the shapes, the markers on like a scatter plot, whether or not to have a grid, whether or not to have a legend for the figure. And where this is, mostly used would be like if you're creating a complex figure for publication and research. Or if you were going to put something up, in front of the board of directors or something like that, you can pretty it up just like you do with all those mouse clicks in Excel or Power BI. You do it with code. Okay. Again, guys, if I'm just hoping you're going, oh, okay. I'm not expecting any kind of mastery. I'm not even conferring any kind of mastery. Okay, so we can do some statistical plots. We're gonna go back now and get back to getting simple. Like I said, I really need to reorder this presentation. Well, that's why I developed that simple ugly charts notebook, was to start simple and then move into this sort of stuff. But that Anscombe subplot thing is a pretty gnarly beast. I probably need to just get rid of it. Okay, so remember, SNS is the Seaborn library. So SNS.get dataset names will show you the built-in data sets in Seaborn. Many of them are kind of famous that you can find out there. I believe they pulled them directly from GitHub, and they're out there on some of them are out there on like Kaggle. So especially the Anscombe data set, that's really famous. But yeah, how many we got there? 10, 15, 16, 17, 18, 19. Did I miss one? Anyway, one that you see in a lot of tutorials out there is called tips. And we're going to do some work with that one now. So we do tips. We'll create a data frame from the Seaborn tips data set, and we'll do a describe and an info. So we've got what this is the bill from a restaurant. It's got the total bill for the party, the tip amount, the sex of the person paying, whether or not it was a smoking table, the day of the week, and time of day, and at like breakfast, lunch, dinner, and the size of the party. So like I said, you'll see this out there being used in tutorials outside of the class. So it's reasonable to take a look at it. And here we'll do a tips.head gives us the first 5 rows. So yeah, there you go. Time is just lunch and dinner. Okay. There are generally 3 types of data sets we might use: univariate, bivariate, and multivariate. This is going back to stats review. And why review stats? Because everybody loves statistics. Okay. So when we have one variable, not a lot you can do. So we can plot the counts if it's categorical. So what's a discrete variable? It either is something or isn't, like a 0 or a 1. Continuous variables more like body weight, like we saw in the penguins, where it's I mean, yes, there will be a finite number of decimals that you can store, but generally speaking, continuous variable is on a continuum, and categorical variables is like species or island that we saw, Gento chin strap and Adelaide penguins. So we're going to subset the tips data frame, but we're only going to grab the day series. So tips day will become a panda series. So we'll run that code cell. And of course, we get the numeric index on the left, but all we're getting now is the day of the week. And remember, the way to count the unique occurrences of a categorical variable like that is to do the value counts. So tips day counts returns an indexed list with the category as an index and the count as a value. Okay, once you've got value day counts, you can do a good categorical chart like a pie chart, which we did before using pandas, right? Well, pandas is just calling matplotlib. So this will show you what we're talking about. Tips day counts, since all it is categories and counts, works really well. But I want to try something here. This plot.show is occasionally for me not terribly intuitive. So I want to comment that out, and I want to run this plot.py method. So we're using the matplotlib pyplot module PLT that we imported .py method, and we're sending it this list of counts, tips day counts. And I want to see something here. Yeah, it shows it, but it looks weird. There's something about plot.show that makes it work better. I need to get a little bit smarter on when to use plot.show. It removes the summary data from the plot display. But sometimes when you're building these things, you're adjusting the plot, but it doesn't actually display until you hit plot.show. I see somebody on chat. Okay, thanks, Alyssa.
Yeah, Don, we're gonna hop off.
Okay.
Thank you.
Yep, you'll see an assignment to start working on. Don't sweat it if
Okay,
it's late.
perfect. Thank you.
All right, see you. Okay, so that's the default with no parameters. But you notice that the pie chart in Python or in pandas looked a little better because when pandas calls matplotlib, it's calling it with some parameters to make it look a little better. So when you're down in matplotlib, kind of lower in the weeds, you have more control, but now you got to start passing stuff that makes it look better. And that's what we're doing in the next code cell is creating some stuff. And again, I'm gonna comment this plot.show out. I get to know this thing a little better all the time, but okay. So all we're doing here is creating a list, a Python list of acceptable color letters. I'd have to look in the matplotlib documentation, but these are yellow, green, red, and cyan. There are a dozen or so legal colors to pass. And you pass a list of colors that matches the size of your data. So we're going to create a list that is Y, G, R, and C. We're going to grab the index from tips day counts, which remember the index is the days of the week, and the value is the counts of how many checks, how many tickets there were on a Saturday, how many tickets came in on a Sunday, that sort of thing. So here's some parameters we can set. Now we're setting variables here, and then we're using those variables as arguments when we actually call the plot.py method. So we're setting up a list of colors. We're setting up basically a tuple of index values, and we're setting up a tuple of 4 numbers to show. You'll see when we do this here. 0.2 means that second wedge is going to explode by a little bit. Explode meaning, come out from the rest of the pie. So when we finally call plot.py, tips day counts is our data. That first parameter is our actual data. The rest of these are optional. They're keyword arguments, or those quargs that you see in the documentation. So we're passing it tips day counts to be the data, just like we did in this previous code cell. Plot.py tips day counts. And this is plots.py tips day counts. Same call, but we're throwing it a bunch of optional arguments that make it pretty. And like, you can look at the documentation, there are dozens of arguments that you can use to adjust the appearance of these plots. Okay, so we're doing the same thing. Give me a pie chart of tips day counts. But I want colors to be equal to this list of colors that I made: yellow, green, red, and cyan. I want labels to be equal to the index of tips day counts, which is the 4 days of the week that the restaurant is open. Explode means don't explode anything for the first pie wedge, but for the second one, come out 0.2. I don't know exactly the value of that parameter. You'll see the effect. And then 0 and 0. So we're only going to explode 1 pie wedge based on that Python tuple that you're passing it. Auto percentage, couldn't tell you. Counterclockwise equals false. Pretty sure that's the order of the pie wedges. And then shadow equals true gives it a little drop shadow, and you'll see the effect of that. It kind of makes it a little more like a 3D effect. And then we are setting using the title method better pie chart. And Matplotlib remembers this stuff in between calls, so it remembers the state of the figure, which is just kind of a feature you got to get used to. So I'm going to hit this without a plot.show, and yeah, we get the summary statistics up here. But if we just say plot.show, we get, so we're seeing the better pie chart we did with the title method, and we see the labels are Thursday, Friday, Saturday, and Sunday, which is the index from our value counts up here. The actual pie data is this 87, 76, 62, and 19. So you can see that Friday is much smaller than Saturday or Sunday. Friday is, yeah, this little 7.8%. Auto percentage. Yeah, so we're sticking calculating the percentage and putting that on the pie chart. So yeah, like I said, there's so many options in these different charts, so many different parameters. And this explode shows you now, if I change that to so I'll double it, 0.4, and rerun it. It comes out even further, 0.9. At some point, it gets ridiculous, right? So that's the effect of these parameters. You can just kind of, play with them, and see the impact. I'm curious if we tips.k.index, is that a string variable? Can I call dot upper? Nope. Probably have to convert it or something. So you can see the impact. I'm curious if I just randomly try a B here instead of a C. Yeah, I get a deep blue hue, and you can. That's another. You can set the color palette as a parameter as you're going through building these charts as well. So pretty much, let's try see what a P looks like. That's some kind of purple. Oop. Nope, doesn't like P. Not a valid argument. How about V for violet? Nope, doesn't like that either. YGRC. Back to cyan. There you go. And I guess I wanted to print whatever labels is. Yeah, categorical index. Yep. It's just the days of the week. Okay, yeah. So one way to look at categorical data, right? The categories being days, the 4 days of the week. And then you go through and you count up how many value counts there are of each of those categories in your data. All right. So we will do another simple bar chart, and that does the same kind of thing. But underlying this, the x-axis is the index to tip day counts. So that's where we get the Saturday, Sunday, Thursday, and Friday. And we could reorder those in that that sequence. But we can adjust the widths of the bar if you want one to stand out, which we're doing down here. We're setting all the widths the same except for the second one, which we're making 0.8 instead of 0.7. And again, we're setting the colors of the bars away from that default where they're all blue. Plot.bar is just like plot.py, but it calls the bar chart method. Using now tips day counts index as the x index, as the x value. So that's what's going along. Tips day counts, remember, is the day of the week: Saturday, Sunday, Thursday, Friday, Friday, Saturday, Sunday, Thursday, Friday, Saturday, Sunday. Tips day counts is the number of tabs, number of bills that came in on those days of the week. And then we're setting width equal to widths using this list up here, and color equal to colors using this list. And then we're setting a title, we're setting a day, we're setting a frequency, and then at the end we clean it up with our plot.show. Okay. So that's another way to show categorical data. That's important because we're doing a real simple example of this stuff in the exercise that I'm going to turn you loose on pretty quick here. Okay, now a histogram, just like we showed at the basic charts. When we get down to Matplotlib, we have total control over the histogram. So what a histogram does, yeah, there's a little note here on the statistics. It takes what can be a continuous variable, or what is a continuous variable, and puts it into bins. And the bins fill up with however many values fit in those ranges. And you'll see here in a minute, we get really ultimate control over the bins, because you don't necessarily want the bins to be the same size. You need to control the starting and ending value of each bin, and you can do that. You can do that in Excel. You can do it in Python. And this is another example where it gets pretty gnarly. But it shows you the amount of control that you have. So in this first one, we're just going to do a real simple one. We are going to plot the total bill column. Tips total bill is just a column in a data frame. And we're going to say, give me 10 bins to see if that gives us enough granularity. And it's okay, but you know, we could say 25 bins, and you start to see that it's not quite as even and pretty. But I'll put that back to 10 and run that. And Python automatically, just like Excel, automatically decides the start and end value of each bin, the bounds of the bin for you, kind of based on the data. It just looks it up and comes up with what looks logical. Okay, so that's a real simple, ugly histogram. So now this next one, this is where we start getting pretty gnarly. And we are going to import one more library. Underlying pandas is a library called NumPy that lets you work with numbers in a list, like an array in basic computer science, a NumPy array. So really a panda series at its heart is really a NumPy array. So anyway, I think we use a NumPy function down here in a minute. So I'll import both of those libraries. We had not used pandas yet. This was all Seaborn and Matplotlib, Seaborn data sets and Matplotlib plotting calls. Okay, I say this is a good point before we get into this very cool but very gnarly histogram. Let's take a break and we'll come back at 10:30. All right, welcome back, guys. There's yeah, some more Matplotlib parameters we're going to go over here to kind of show you the nature of the control you have over these different visualizations. So I went to the Matplotlib official documentation to see what legal colors were available. And yeah, I was looking for purple. It's M for magenta. So B, G, R, C, M, Y, K, and W are the legal single letter colors, but any of these values will work in that colors argument. So I went back over to that bar chart and I used orchid, sandy brown, deep sky blue, and dark orange for my colors, which is hideous, but just to show you that, yeah, you use the keyword for the color or the key letter for the color, and you can specify the exact color. And as we get into Seaborn, probably Thursday, there are like themes you can set, almost like, you know, how in Excel, there are color themes, and one set of colors might be kind of on the blue end, and another one might be kind of on the red end. Well, there you can do the same sort of thing. Seaborn is kind of how you pretty things up graphing wise or charting wise. So anyway, we were doing bin size, and pretty soon here, I'm gonna hit an error that I either have to fix or just blast on past. We are going down here, and we're going to create a histogram with custom bins that match like a letter grade more accurately than if you did an automatic histogram of a academic score of a 0 to 100 score. It would bin them like ignorant to what it really is, which is it's really a grade. But anyway, just as an example, we're going to read in stats exam 3 scores. I posted that to the classroom, and we're going to take a look at what we got there. It's just scores. That's all we're looking at, is the raw score of a statistics exam. Okay, so we are going to, but it's a data frame. Even though it's only one series, it's still a data frame because we read it in as a data frame. We're going to add a calculated column now called percent. It's the rounded percentage to 2 decimal points. So it's a 0 to 150 score that we are now calculating to be a like you'd think, a 0 to 100 score. Okay, that's what that did. So yeah, this is just another example of how you can do all sorts of manipulation to create a calculated column. That's just pandas, just data frame working. So if we look at a histogram of the test percentages, it looks like a normal histogram, but that's really not the way we want to do our bins, right? We want to do cutoff points for the bins, so that it looks more like, an F, which is 0 to 59.99, whatever, and a D is in the 60s and a C is in the 70s. But there's a few finer points here that we're going to do. And again, this is still all just pandas. This is still just data frame manipulation. So there's a cut method that will create intervals in a pandas data frame. And you send it a list of values for the beginning and end of your bins. We'll see what that looks like. Okay, and we'll get to what the square bracket means, like exclusive, and the round bracket is inclusive. So we'll see here in just a minute what that means. So, but it goes through when you do letter grades, it goes through and it's the same index, and it shows you in that data frame where that value fell into which bin. Okay, so it's an interval, kind of a complex data structure. Okay, so now we can do value counts in that letter grades interval, so we can see how many test scores fell in the 0 to 60, the 60 to 70, 70 to 80, and so forth, using value counts. So we had 155 C's, and this is as we walk through, and I gotta credit my my colleague Mike, Dr. Ellis, on this. This is all his. There's some things that are slightly wrong. So what's with the open parenthesis and closed square bracket? For the interval data structure, it shows which up to and including inclusive or exclusive. So the square bracket is inclusive. So that means that 70 to 80 would be included in the 70s or the C's, and we don't want that. And just like the 80 and 90, that would mean that a perfect score of 90 would be included with the rest of the 80s, and that's not right. It's 90 and above is an A, right? So we got to kind of shift the side of the bin that we want to be inclusive, and that's what this next code cell does. And again, this is just kind of advanced pandas stuff. Don't sweat it. I'm trying not to take up too much time with this. So this will adjust our bins to show which side is inclusive. So now the 60 inclusive up to, but not including 70. So now the parenthesis is now on the next to the upper end of that that interval to show you that that will not be included in that interval. But down here, when you see 70 to 80, it's got the square bracket next to the 70, which shows you that 70 is included in the interval between 70 and 80, excluding 80. So that's in the 70s. So that's how you set up an interval for data analysis in pandas. Interesting tidbit. There's just so much you can do, so much to learn. It is staggering. Okay, so we are adjusting the last bin value because it was cutting off 100 percentages here. Whoop. That's what we got in this markdown cell here. What happened to the hundreds? Okay, so we got to adjust that up to 101. So our grade names now for our bins are F, D, C, B, and A, like it would make sense. Okay, we'll run all that. So we can now use the letter counts as the basis for a histogram of the grades. So we print those out. We sort the data accordingly from underachiever to overachiever. I'm sorry, the other way around. From A student down to maybe think about getting a refund, dropping this class. And then plot it as a basic bar chart. And I think this might be where I start to crash. Kablam. Yeah, I gotta figure out what I'm doing wrong with this call. I thought I had it figured out, but I did not. So we will move on because I think later it works out okay. And then complete the histogram. There we go. I got to figure out why my code works here and what I did to screw up. Because this is what we're looking for. Here is our completed histogram with the bins in the proper order, the data assigned to the appropriate bin, the colors coded appropriately so that you see, some warning yellow alert for folks that are nearly failing or failing the course. And that's what all that does. So, I mean, I don't know. To me, like I've said before, this would probably be easier and more intuitive in Excel. But once you get this going, it may work out to be better. But to me, Python is something that's it's more powerful when it's used in a script, not when it's used interactively like this. But there are other people that do this stuff. They do it in R or do it in Python all day, every day, and they just know these parameters like the back of their hand, and they just work magic with it. But that code drew this histogram. But for some reason up here, when I am goofing around with things, I get an error, and I got to take the time to go back and figure out what I did wrong in this call. something in that line of code is sending out a parameter that Python doesn't like. Argument must be a string or a number, not an interval. I gotta figure that out. And once you figure it out, it's like, oh, but yeah, it can be frustrating while you're doing it. So that's a complicated histogram bar chart. What do you call it? Yeah, bar chart, where you convert a continuous variable into bins according to some sort of logic. And that could be something where you were assigning a value to a type of account, or a score to a salesman or something like that, that based on this much sales, we're going to call them a this. And if the bins aren't equal size, that's when the automatic formatting just falls short, and you have to take control and tell it what to do. So we'll go on back into some pretty simple, and then we will break for the day here. So remember, a box plot, box and whisker plot, is a way to, it's kind of like a histogram. The line in the middle is the median value, and then the first and third quartile. The whisker shows you how spread out the data is, and then these dots are your outliers. And we're looking at our percentage column that we calculated previously. Okay, now bivariate data, looking at two different variables. Again, that's a scatter plot. So we're going to do a couple of those real quick and dirty here. So DF2, we're going to read in that other file, stats, homework, and exam CSV. Take a look at that, df.head. And create the basic scatter plot of the homework column, which will be our X, and our exams, which will be on the Y, and then plot.show. Yep, and there's our exams going up the Y. So it looks like there may be generally a correlation. So maybe, just maybe, people that do their homework, which is the independent variable, people that do their homework do well on the test. Duh. So of course there's a correlation. So we will do a correlation matrix, df.2, using the .core method of the data frame. And sure, 0.6, that's a fairly strong correlation between the score you got on your homework along the x-axis and the exam score you got on the y-axis. And then, yeah, multivariate gets interesting. Let's see what we got here. So we're converting sex to zeros and one. Yeah, in your notebook, somebody tell me, look at your notebook. It's somebody that's following along. Is anybody following along with me?
I am.
Seth, you don't have in place equal true here, do you?
No.
Yeah, this was giving me trouble. Yeah, I spent a couple hours reviewing all of this and refreshing my memory of how all this stuff works. You don't have in place equal true. What this rename categories is one of those things where it returns a value, but it doesn't change the data for the underlying data frame. It just shows you what that would look like. So you need this in place equal true operator, which is something that you see frequently when you're dealing with pandas data frames. You think you're doing a method that monkeys with the data, but it doesn't. It's a temporary result. But if you actually want that method to save the change, you have to have the in place equal true parameter. So for you guys that are following along, or anybody watching the recording, this will goof up unless you add in place equal true. And I just found that last night. And then we'll look at the first few lines. And we get here you go. Here's an example of that warning. In place equal true is deprecated. Removing unused categories will always return a new categorical object. Okay, I would have to digest that. But this is the sort of, hey, by the way, we're not doing it that way anymore. Change your code. And I think I'm supposed to change rename categories to this, to a different method. So anyway, but if you have the in place equal true, it actually does change the category from 0 or from female to 0 and male to 1. And now we can use that more numerically, like, so we're going to do a scatter plot of the total bill using sex and dot size for party size. This one may goof too. Nope, I got it to work. Now there may be something above this or different that I pulled. Are you getting an error, Seth, when you try and run this scatter plot?
I didn't try the scatter plot yet, but I did get that.
You're really faint. I can't hear you.
Sorry. No, I haven't tried to run that yet, but I did
Okay.
get that pink error on the first one.
You did get
Or
the pink.
Yeah, on the previous one, I got that.
Yeah, but on this one, it seemed like I was getting an error and I had to eliminate a parameter or something, but I can't remember. I did so much running around and graphing in the last few days getting ready. I can't remember for sure if it was this one. But
I just ran it and it didn't throw anything up.
it works fine. Was there anything above it that threw an error that I didn't get? You know what I mean? Does your data frame, does your notebook look like mine?
As far as I can tell, yeah, these two look exactly the same.
Cool.
I added it in place true there.
Yeah. Okay, cool. I might be thinking of notebook 15. So yeah, there's a scatter plot, but now we can use the size of the dot to show how big of a tip they left versus what sex they were. So it kind of gives you a way to look at a third variable when you change the dot size in a scatter plot. That's the generic takeaway, is you can change the dot size in a scatter plot to reflect a third variable. Multivariate analysis. Okay, and these last, go ahead.
Can you make it bigger? Like, that's sort of hard to see everything on that. Like, is there a way to make it take up more space so that it's easier to see what's going on?
To make the entire plot bigger. Yeah, that would be good. Can I take that for homework?
Yeah, that's fine. I was just curious.
Sure. I'm sure there is, or I think there is. And you can also save these as a JPEG, and they save in pretty good resolution so that you could save it as a JPEG and then make the entire plot larger. But that's a good point. I don't know why it only uses this much screen real estate.
I mean, maybe just so that you can get kind of a look at it, but like, I think it would be kind of hard to use just that in a presentation or anything when it's not, I mean, it's not really clear.
True.
You know, there's a bunch of stuff going on there.
Yeah, you're right. You're right. I agree. And the colors are horrible. I agree. So making the overall plot larger. Hang on just a minute. And I still have to incorporate subtotals into my pivot table. Like figure size, or there's got to be an argument in there, I would think. So these last few are right back to what I was doing. I took some of these examples and put them in that basic plotting notebook so that this is where all of this should start. So we're going to look at a histogram of total bill. And again, when you just use pandas, you don't have as much control over any of those parameters. And there's our total bill versus tip. And of course, as the total bill goes up, your tip goes up. And a hex bin looks kind of like a scatter plot. You can see but it throws in kind of the density of the plots in into a hexagon, so that if there's multiple points in there, it shows better, because you could have, can you see my mouse pointer, guys?
Yes.
You could have 300 values that are obscured based on your dot size. You know what I mean? The hex bin plot will help bring that density to light, where a normal scatter plot, it might be obscured by, because you got too many dots in there. So the hex bin gives you a way to kind of reflect that, how many occurrences were in that hex. So that the scale is on the right here of how, as it gets darker, you had more values, and there's that one. And you're right, Seth, that's tiny. I gotta figure out a better way to show that, especially if you're presenting like this. I mean, if you guys are on a laptop looking at my shared screen, this is microscopic. So there you go. I made a note to fix that up. And then, box plots of all the variables. These are good ways to look at apples to apples, particularly if it's on the same scale. Now, we got lucky here with tip and total bill are dollars. Party size is still using the same scale. So that might be trouble. But if you just say data frame .plot .box, it will plot all numeric columns. In fact, a lot of these things are like that. If you don't specify what data, it will try and plot it all, and anything that it can plot. And we'll get a little bit into that next time as well. And then if we just want a box plot of tip, we use the Panda series method .plot.box, or I'm pretty sure you could say tip to tip .plot kind equal box as well. So there's more than one way to get at it. And that again, that shows you the median of the data and how spread out. Look how it's a lot more tailed off to the right than it is low, which, yeah, you kind of think you can only get so small a ticket at your lunch counter. Okay. And that's notebook 14. We got one more, and then for graphing, then we'll put that to use. Hang on just a minute. Let me all output clear, save, and file close and halt. So now the exercise for the rest of the day, it may only take you minutes. We'll see here. Is basic Python charting exercise. That's a notebook with it's literally 5 or 6 lines of code, guys, that we've been over twice now in these notebooks. Between basic charts and 14, they're literally with pandas. So you just throw in the default but extra credit if you want to do the same type of chart that I asked for. I also ask you to do a little bit of thinking about what kind of chart do you use with what kind of data? I can pull that up real quick for the recording as much as for everybody that's still here. Python, not the one with the answers. Python charts exercise is the clean one. Yeah, so you don't need any files. All you're going to do is use a Seaborn library that looks at different models of cars and their miles per gallon and their horsepower and whatnot. So these are the instructions. So you're going to create a data frame, and I don't tell you which kind of chart to draw. So I'm hoping you'll read my comments here and be able to tell what type of chart I'm looking for. So it's sort of a test like that, which is, I mean, I don't think it's going to give anybody too much trouble, but if you do have any troubles, please email me. And some folks are attaching a JPEG screenshot instead of just attaching the IPYNB file as a raw attachment to the email. But if you want me to look at anything, and that's not just this one, that's ever anything, just attach your code in a file and I will take a look. So if you guys could knock that out with the time remaining today, I would appreciate it, and upload it to the assignment. Any questions? Once, twice. Okay, guys, we'll see you Thursday. And don't forget, next Tuesday, we're doing MongoDB. So we got a really good opportunity at a more advanced topic with a new kind of database, a NoSQL database on Tuesday. Okay, I'll see everybody Thursday at 8:30.
All right, thank you.